So we are going to start with the digital design using Tinkercad, which is the first step for the engineering prototyping. So the first thing, we are going to type tinkercad.com, and the next step is going to be signing in. Right there. In our case, it's going to be our email or username. Clicking next, signing in. And this is the main page of Tinkercad. Today we are going to use a circuits, which is that section, and we are going to create a new circuit. This is going to be the page in which we are going to be working. The first step is going to be changing the name of our project. So in here, we are going to type the name of our project to have a record of every prototype. So the next, we are going to search for our components at the right side. And the first one is going to be the microcontroller. We are clicking on it and dragging it to the left, and we're going to place it at the top of our page. Our next component is going to be the breadboard. We are going to be using the small breadboard, which is this, and placing it below the Arduino microcontroller. As soon as we have the two components, the next one is going to be the power to our breadboard. It's important to know that this breadboard has two rails, one negative or blue, which means ground, is represented in Arduino by GND, and it has another rail in red, which is positive, and that means 5 volts. So those are going to be the connections. They are connected horizontally. So if you connect in ground in any of the pins that are horizontally, they are going to be all connected to ground. Ground is represented in Arduino as blue. In electronics, we use the blue color for ground. So we are going to change the wire to blue. So today we're going to use only ground. Now, next is going to be our components, the two components for the circuit, which is an LED. Dragging it to the left. This LED has polarity, has two legs, and by clicking on every leg, we will see the connection. In case of the left one is the cathode. Cathode is negative, and we can use the section of notes for typing there the name, I mean, if it's cathode, anode, depending. So in this case, it's gonna be cathode, which means negative or blue. Like that. So the next one, the next one is gonna be the right leg, and the right leg is anode. Anode is connected to our microcontroller and is the positive side, which is 5 volts, and is red. So that way you have identified the two connections for the LED. Now, for controlling the power of this that is passing from the microcontroller to the LED, we need a resistor. So we are going to type our next component, which is resistor. And we are going to drag it to the left. We need to click on the resistor because we need to change the value. value is gonna be, in case of our projects, 220 ohms resistor, which is the omega right there. And your resistor must be red, red, brown. So the resistor is ready. This is gonna be connected between the cathode of the LED and the blue section of the breadboard, like that. So that way we already have the cathode connected, and the last part is gonna be the connection of the anode or right leg. This right leg is gonna be connected from digital 2, which is at the top of our microcontroller, all the way to the right leg of our LED. By clicking on the wire, we can change the color. I suggest to use the color of the LED, like that. So we already have the connection ready. And basically, this is the wiring. Our next step is gonna be testing the project by typing the code. So we are going to the section of coding. By clicking on blocks, we are going to look for text, which is the one we are going to use, continue, and then we will see there a sample of a code that basically is for testing if the microcontroller is working. So if we close the code and start the simulation, we are going to see 2 LEDs on the microcontroller blinking. That means that so far we are doing great. Our wiring is correct. So we are going to stop the simulation. We are opening the code, and we are erasing the code that Tinkercad is giving us. It's very important to notice that we cannot work if the simulation is running. Every time we want to modify the project, we need to stop the simulation. So that's why we've stopped. Now, the next step is gonna be typing the code. We need to type the integer, which is gonna be LED equals to number 2, because we have the connection to number 2, and we close the sentence always with semicolons. The next one is gonna be the void setup. So this void setup is gonna be in parentheses and a bracket. We are opening a bracket, and we are going to type, this one is gonna be a pin mode, opening parentheses, and it's gonna be an LED as an output. Output to indicate that we have a connections in the digital side, and we have one LED. So in C++, when we have 2 words, we need to separate them by using a capital letter. So that's why pin mode is in capital letter N. So pin mode is gonna be only LED. So we close with a bracket the sentence. And our next one is gonna be the void loop. Void loop is what we want the LED to do, or the function. So we are going to write digital write. We have an LED in high. And this one means that the LED is gonna be on. And then the timing, we need to write the timing for this LED being on. So we are going to work with 500. In this case, C++ works with milliseconds. So 500 is gonna be milliseconds. And then we are going to write digital write, parentheses, LED. And now this is gonna be low or off. And this one is gonna be off for 500 milliseconds as well. And basically the code is ready for one LED. So we can close this area of the code and we can start the simulation to test the project. So our project, the final digital design, looks like this. So some of the features that Tinkercad has are right at the top. So if you want to rotate one of the components, so you can click on the component and go to that arrow at the left, and by clicking, the component is gonna start rotating. So like that. Or if we add a component that is not supposed to be there, we can use the next icon, which is the trash bin, and we erase components like that. As well, the third button, which is the undo, this one, so we can erase components from our project. And the next one, just to add them, depending what we want to. The fifth one was the notes that we were working with. And this one is going to be for if we don't want to see the notes, we click on that and the notes disappear. So those are some of the features. There is another one at the left, which is the zoom. When the project is is big, we can resize it by using the zoom. So in the section of the code, there are things we can change. And one of those are the delays or the timings. What would happen if we change this one to 100? So the blinking is going to be different. So let's take a look what happens. So our LED is going to blink faster. There are some other features that for the coding, and we can as well add more LEDs by adding lines to our code. So in this case, if I copy and paste another integer, and if that happens, I need to change the name of the value. That's why LED2. And of course, it's going to be connected to the number 3 of our microcontroller. It's going to be a pin mode output, but now LED2. And the same thing is going to be for the void loop. We are going to add another LED that is going to be blinking on and off with the same delay. So if we do that, the next thing is going to be to adding the components to our digital design. So we are taking another resistor, changing it to 220, and then we are going to get another LED connected to one of the pins on the breadboard, LED, like that. So we can move a little bit the nodes, so we can give space for the second LED. We can change this one to green since our wire is in green, so why not to have the green LED there, like that. So we are going to start the simulation to see if our project is correct. And we have a successful project. So our next step is going to be the engineering prototyping. So we are going to follow the instructions built in Tinkercad to start to design the wiring. So the first thing here is going to be the connection of the ground. So we are going to take one cable. We are going to look for the ground, which is in one of these sections of the microcontroller. We are going to connect the pin, and then this one is going to be connected to the blue section of our breadboard. So we connect the pin like this, and that way we have the first connection. The next one is going to be our LED. So LEDs, they have a polarity. So in here, we have the long leg. This long leg goes to the microcontroller, and the short leg is going to the blue section of our breadboard. So we are going to connect this LED right here on our breadboard. And then, as I mentioned, the short leg is going to be connected to ground, but we need a 220 ohms resistor for controlling the power of our LED, or the power that comes from the microcontroller to the LED. So the short leg is right here. So we are going to connect one resistor between the LED and the ground, like that. There. So I'm going to, there. It's important to see all the angles of the connection, like that. All right. And the next step is gonna be the long leg, and this long leg is gonna be connected from here. Let's see, there. So like this, to the number 2 of our microcontroller. So we are going to look in here for the number 2, and then we connect like this. So that way we have the two legs connected, just making sure that the resistor goes right in front of our leg. Is very important to check that. So in here we are going to do the connection just like that. The last thing is gonna be the USB cable connected to our microcontroller and goes to our computer. Our next step is gonna be the programming. For programming in Chromebooks, we are going to use Arduino Create. This is the main screen for going to the website. At your right top, you will find the signing in. So we are going to sign in, and it's asking for a username and password. We are going to log in, and will take us to the screen for web editor. So we are going to click on it, and that is going to be our website in which we're going to program. So in here we have a the screen where the code is going to be typed, and making sure that we are the connection at the top, which is Arduino Uno. If we don't have it, we can click on the arrow at the top and we can look for our Arduino. So we are selecting other boards, we are typing Arduino Uno, and we are going to click on the first one. It's going to give us a port. In this case, it's going to be COM10. We click OK, and we are ready with our first step. Second one is going to be erasing the code that Create is giving us, and we are going to paste the code that we typed in Tinkercad. So we are going back to Tinkercad. We are going to copy the code and pasting on our Arduino Create, and it's going to be like that. So the next one is going to be, we need to check if the microcontroller, the USB, is connected to our computer. And those two arrows at the top is for uploading and saving our file. And the second one, the check mark, is going to be for verifying and saving. So by clicking there, we are programming our project. We have to see a green line at the bottom of our screen. saying success. So this is gonna be the final step for our project. Checking the white rectangles at the right, which is verifying the sketch. And then we can take a look at the project to see if the LED is blinking. In some of the cases, when the program is correct, but the project is not working, we need to check the wiring. Can be a connection from the ground to our breadboard, or can be the connection to our digital side of our microcontroller. Sometimes the resistor is not in the ground place. And the last is the connection of the LED. Remember, LED has polarity, so if the short leg is not connected to ground, the project is not going to work. So I'm going to take a look to the LED. So I'm going to take the LED and in here. So my long leg is connected to the resistor, which is incorrect, has to be the short leg. So I'm going to flip the LED and then I'm going to reconnect, and then the project is gonna work.